So hi, Eric Baldeschwieler. As introduced, I've been working on Hadoop since the project sort of was called Hadoop. And it's kind of a happy accident. I've been making a couple notes because I wanted to make sure I was talking about different things. All right, so why Yahoo took this prototype and then built an internal service that now runs on 42,000 computers, has roughly 200 petabytes of storage, raw storage involved. And it took about 300 person years of investment in open source software to make this thing work. So if you do the numbers on that, that's a lot of investment. Right, so why is a company whose business is serving web pages interested in plowing that much money into this thing? Right, it's kind of a happy accident actually, because this project started out. Before I was working on Hadoop, my previous job was chief architect for web search at Yahoo. So web search is of course a big data problem. You crawl the entire internet and then you process the data. So I've been doing that for a number of years before Hadoop. And Hadoop started out as an attempt to rebuild the private systems to do that in a more open way. The sort of primary challenge there was take an input set that, if uncompressed was several petabytes, compressed was still several hundred terabytes, and effectively kind of just rearrange it, sort it, index it, take all of the URLs and all the text about all the URLs you know about, from all the web pages you can find, and build an index that says for every web page, this is every incoming URL and all the text about that URL. That was kind of one of the first jobs we wanted to do on Hadoop. But that's kind of a multi-petabyte sort problem, and you can't process that kind of data on any system that existed at the time. So we started building out a solution to that. And that was a multi-year project, right? The thing we started with worked on 3 to 20 nodes, and we started working on it. We got up to 300 nodes, and we had a roadmap to get it up to 1,000 nodes and then 4,000 nodes. But we wanted to show some value right away at the company. So we put up research clusters where the data scientists from other parts of Yahoo could start doing anything they wanted on a few hundred nodes of Hadoop. And this thing just exploded in a way we never anticipated, and it became our full-time job. Right? Because what happened is it kind of became the new data warehouse, is not the right term, but I'll call it that, for Yahoo. There's all these data sets that people had wanted to use, but they just couldn't because the data was hundreds of terabytes compressed. And so somebody's full-time job to pick the subset of the data they wanted, go to the people that were producing that data, try to get that subset, get it onto some machines they'd beg, borrow, steal, or buy, and then try to do some science on it. But so with Hadoop, all of a sudden, people just stopped having to do all that IT. They could put the whole data set on a computer, and they could go to a central team and say, hey, you already have that data. Can we have compute there? And we'd say, yes. People's minds would just explode when they'd say, I've heard you have Hadoop. How do I use it? Do I go buy some computers? No. I'll tell you what, we'll give you an account. You can have all the data about every click in Yahoo for the last 2 years. You can have every web page you've crawled. You can build your application. You'll have hundreds of computers. And if it works, then we'll talk about, buying some more computers so you can do it regularly. And the sort of productivity explosion that this created funded all that investment. Right? It changed Yahoo. Because if you think about it, the reason Yahoo poured money into this and gave it away was because they thought that by making it open source, they could hire more people into Yahoo who wanted to work with this technology. People came out of school trained. People built their companies on Hadoop. When Yahoo acquired them, the integration was easy, et cetera. That all worked out. Pretty exciting. But so what we started to see was teams would go to the central hardware planning groups and say, well, we will promise more ad revenue for Yahoo. This is $1 billion number, and we'll add several percentage to that if we can get some more thousands of nodes of Hadoop. And that's kind of an easy calculation, right? Millions of dollars investment, tens of millions to hundreds of millions of dollars of return. That pays back pretty fast, right? So that's why Hadoop exploded at Yahoo. So that gets us to that's just sort of a bunch of context, right? Is that it made it possible to do work on data that just wasn't possible to do before. And as I said, that was a happy accident. We were building it for a specific use case. But what we found was all sorts of other use cases existed. People ran experiments. Those experiments justified building production systems. Those production systems drove more investment into Hadoop. And that got us to where we are today, which is that multiple companies building Hadoop, and self-funding the further development of Hadoop. So when you look at where does Hadoop fit into the enterprise, it's kind of an interesting sort of question, because Hadoop, a lot of people want to know what system does it replace, and the answer, it's not replacing systems. It's kind of a new system. So if you look at a classic enterprise, you got a big database, you got a big warehouse, all right? And you've got sort of ETL that's pulling data out of your transaction systems and pushing it into your warehouse systems, and that's a thin straw. It's very structured. If you want to change what's in the warehouse, you have to go back to central IT and have a negotiation, an implementation plan, a budgeting discussion. It takes a while. So then now you get Hadoop comes into the picture, or the big data refinery here, right, where you have all this unstructured data. You can pour it into this low-cost system. And then that low-cost system could produce interesting results, which then get used by your existing production systems. That's something we saw at Yahoo. All of a sudden, you have a search suggestion system, a spelling suggestion system that's driven by dictionaries produced on Hadoop with data. But that data is then pushed up in your traditional serving systems, your websites, et cetera. Oh, I pushed the wrong button. Too many buttons. All right. All right. So now, instead of just throwing away the data you don't ETL into the main system, you can put that data back into this low-cost, high-volume store. And when your warehouse, people also have to roll data out of their warehouse because you buy warehouses by the terabyte, right? You can buy, it's very expensive to keep stuff live in a current best-of-breed warehouse. So when you want to just archive it, you can archive it live into Hadoop. And so you get this new ecosystem where your traditional systems still exist, and they're deployed doing what they were doing, but the data is living a lot longer. Instead of dropping a lot of data you were dropping before, you're putting it into Hadoop, right? So, and then you see this sort of Hadoop interacts with these systems. You've got Hive, which lets you do sort of exploration of your big data in a way that looks like your warehouse. It doesn't have all the features of your big EDW or parallel warehouse, but it's much, much cheaper for very large data sets. It makes possible some things you just couldn't do before. So what you see is specialization. People will take data out of Hadoop and push it into a cube because they want to use a set of industry tools that are much more sophisticated than Hive. But now instead of having to build sort of a data warehouse or a data cube that can answer all possible questions, they can do that late binding. They can have all the data in an unstructured, uncatalogued system like Hadoop, and then pull it out and put it into a cube when they understand what questions they want to ask. So that lets you reuse your existing data warehousing software and hardware much more efficiently. Similarly, your transaction systems get more focused. We've seen plenty of examples where transaction systems are very cost-effective for doing transactions. They're not very cost-effective for doing a lot of other things, like doing sort of reporting that once you have a database, people throw more work at it. With Hadoop, a lot of that kind of cheap background batch work gets pulled out of the databases, and the databases get focused on doing transactions. They do more of them for the same cost. So it's a win-win. So lots of interest. What I talked about is what we have seen happen in big companies, the Yahoos, the Facebooks, a few banks and financials. There's a few places where Hadoop is deployed at massive scale very successfully, some places in governments, et cetera. And the interest is huge. When you do the Google Trends on Hadoop and big data, Hadoop is very popular, more popular than big data most days. So every Fortune 500 company is running a Hadoop POC somewhere. But the process of going from a test bed to a fully deployed production system like what I described is slow and fraught with danger. A lot of places never get out of the POC stage, right? And there's this hammer and nail problem where a lot of organizations know they want to use Hadoop, but they don't really know what it's for. We want to work with big data because we hear there's a lot of value, but people are still struggling to find that value. So what are the solutions? Well, one is to make Hadoop easier to consume. So there's, packaging. Hortonworks, my company, packages up Hadoop distribution. Very similar. I won't describe it again. And then there's this sort of fostering the ecosystem, right? Hadoop only works in combinations with lots of other things. We need to make Hadoop easier to use, which is what that packaging was about, right? And there's a bunch of things that we have done, are continuing to do there. There's the ilities. It has to get bigger. It has to get more performant. It has to get more usable, et cetera. It has, security, data integrity, all these things we're investing in. But a lot of it is just integrating with all of the things that an enterprise already does. ETL, data recovery, making sure that your data is geographically dispersed, high availability, search, system management. You heard a lot of these terms already. And then there's just integrating across the ecosystem. We need to make sure that there's the right APIs for everybody who's building data products to plug into Hadoop in various ways. So that's a lot of what we're investing in as a community, Hadoop community, and of course my organization. So where's Hadoop going? So this is just a list of things that we're investing in right now that we'll see progress on this year. So Ambari is better management and monitoring in open source for Hadoop. REST APIs so that it can integrate with third-party management systems is a big one for enterprise, of course. People don't want yet another console. They want to integrate it with everything else, so there's a bunch of web services challenges there. HCatalog, bringing in a higher level data model for Hadoop. All right, it's great that you can pour everything into files, but people don't want to think in terms of files. So right now Hadoop has this thing called Hive, which lets you describe tables and schemas, but that could be a lot more general and a lot more accessible and a lot simpler to use. So there's a lot of investment in opening up the data that's in Hadoop via much better ODBC, JDBC, so that it can connect to existing business intelligence tools, but also opening up at the bottom so that you can plug in less structured data and new stores. There's an interesting integration problem where you want to let Hadoop talk to other systems and you want to let other systems talk to Hadoop. So there's lots of API definitions going on around metadata there. Full stack HA. Hadoop is composed of many, many systems. We're working hard to figure out how to keep all of those continuously available. Bringing Hadoop to Windows turns out to be a very exciting initiative because there's a huge number of users of the Windows operating system. And it brings, including, for example, if you think of business analysts, most business analysts on Earth use Excel. Making that work really well with Hadoop is great in terms of building a wider community. And then Hadoop 2.0. So Hadoop 2.0 is a pretty major rewrite of Hadoop that's been in the works for 2 years. It's now in usable alpha form. We're using it in a couple of places. But it's still evolving pretty quickly. So the real focus in Hadoop 2.0 is scale and opening it up for more innovation. So today, the existing Hadoop 1.0 line runs on about 4,000 computers, where the target design is more than 10,000, and that takes Moore's Law forward a few years. So a current target computer has about 12 terabytes of disk. A new one would have 36, RAM, number of processes, all goes up. So that's actually an order of magnitude jump in scale when you fight against Moore's Law and bring up the server count. But more interesting, really, I think, is this making it pluggable. Today, Hadoop 1.0 really is all it does is map reduce. Now, people, given a hammer, people can treat a lot of things like nails. MapReduce is a pretty flexible programming framework, but Yarn lets you bring in all kinds of new programming frameworks and some very old ones like MPI and some other things. And then we can talk about latency, but it can be done. So that's just opening up innovation. People can try all kinds of new things with Hadoop. Federation, the file system, is also getting opened up so that people can define new kinds of file systems within the Hadoop storage pool. And then a focus on making sure that nothing ever goes down in Hadoop, that it's always available even through upgrades, et cetera. So I threw in a slide at the end to sort of talk about experimentation with Hadoop, working with research groups who want to play with Hadoop or want to advance Hadoop. So what works really well, right? Observing real usage, I would say, to begin with, right? I mean, it's great to start with real applications. So use the system to do something new and interesting, I think, is a real highlight, right? The first thing to do with Hadoop is actually understand it, figure out how to bring new applications to it, do real work with it. You know, do that before trying to figure out how to advance it. Have a specific thesis about how you're going to make Hadoop better, and come back to the community with data, right? A lot of people, let me talk about the anti-patterns, and that'll sort of elaborate on that, right? There's a lot, because Hadoop is open source, we've got this unique problem that people want to have their papers say, I made Hadoop better and my contribution is in Hadoop, right? It's a great ending of your paper. My work is in Hadoop. But from the community's perspective, all right, I mean, your work now needs to be maintained by the community. So the community is very reluctant to take contributions from folks who aren't going to stay there and invest. So you have to build up capital with the community before it's interested in your contributions, which means a lot of grunt work and grudge work. And that, you know, becoming a Hadoop committer is a wonderful thing, and I love to encourage people to do that, but it's a career choice, right? You have to invest a lot of time in it, and that may not be compatible with graduating if that's your goal. So with that thought, right, it's more valuable to us as a community to learn things, right? To have people try different things and tell us what works, what doesn't work. So like I said, try things, have a thesis, prove that you can make Hadoop better, give us the data. The community will follow good ideas. They may implement them differently than you did, but that's not the point. If you can explore the space in front of us and give us some good pointers, that's really exciting. Another sort of key thing is you gotta understand, you know, people try toy use cases and then, you know, come up with theses for how to make Hadoop better. But a 4,000 node cluster with 100 to 1,000 active users on it is very different from, you know, a 4 node cluster that you run in your lab. And so people try to generalize from 4 node clusters. You got to understand that in normal deployments, most jobs on Hadoop use a tiny fraction of the cluster, and there's many of them running concurrently. So, and in the aggregate, when you have that kind of workload, Hadoop performs pretty well. So it's really easy to say, look, Hadoop could run my individual job faster, and here's a way I could do that. But if you break the average use case when you do that, your work isn't very interesting. So that's a challenge. There are some load generators and some work traces that are available, and I would encourage people to look at those and think about scale out before they propose improvements to Hadoop. But so I think I'll end there, and we'll take questions at the end. All right, thank you very much.